Welcome to less obvious u-substitution problems. So recall for u-substitution, we are essentially looking for an integral that can be in the format of integral of f of u of x times du dx. And then we can go ahead and integrate or f prime of u of x, depending on how you want to see it, right? So if we had a derivative or a function we know how to take the integral of, we wound up just getting out f of u of x plus c if it was the derivative inside of the integral. But the question is, what happens if the format is not so obvious? So we can just try to play around and see if u-substitution works. So if we consider, for example, the integral of x times the square root of 2x plus 5 dx, usually we would take our u to be 2x plus 5, and that x that's out front is certainly not part of du, right? But let's go ahead and just try u equals 2x plus 5, since it's inside another function. Then we have a u and a dx also, sorry, we have an x and a dx also in that integral. So from here, what we get then is we have u equals 2x plus 5. That would mean that x would be equal to 1/2 u minus 5/2. We also have that du would be equal to 2 dx, or in other words, dx is equal to 1/2 du. Right? So if we just plug in straight into our formula, or straight into our integral, we have the integral of x times the square root of 2x plus 5 dx should be the same as taking the integral of x was 1/2 u minus 5/2. Then we have the square root of u, and then dx was 1/2 du. So if we wanted, we can either multiply in our 1/2 or pull it out front. We're looking at the integral of 1/4 u minus 5/4, and then square root u is just u to the 1/2 du. We can simply multiply in that u to the 1/2. So let's go ahead and multiply in u to the 1/2. And so we're looking at the integral of 1/4 u to the 3/2 minus 5/4 u to the 1/2 du. At this point, we're just working with power rule. So we have 1/4 u to the 5/2 if we raise the power by 1, and then we should divide by 5/2. Then we are subtracting 5/4 u to the 3/2, and then we should divide by that new power of 3/2, and then we have plus c. So from here, this becomes, let's see, 1/4 divided by 5/2 is 1/4 times 2/5, which is 1/10. u to the 5/2 minus, then we would have 5/6 u to the 3/2 plus c, and then plugging back in, u was 2x plus 5, so we are looking at 1/10 times 2x plus 5 raised to the 5/2 minus 5/6 times 2x plus 5 raised to the 3/2, and then plus c. So again, this didn't particularly look like a u-substitution problem, but we could still use u-substitution. For another example, let's consider the problem, the integral of 1/x times natural log of x squared. So again, we have here our natural log of x. We know that derivative is 1/x, and we do have a 1/x involved. So we know that the derivative of natural log of x is 1/x. And we do have a 1/x in the problem, so it would make sense to set natural log as our u. So we will go ahead and set u equal to the natural log of x. Then we have du is 1/x dx. And let's go ahead and rearrange our integral so it appears in that format. So we have the integral of 1/x times the natural log of x squared dx. We could pull out the 1/x, so we have the integral of 1/the natural log of x squared times 1/x dx. Then plugging in our u, this is 1/u squared times du. Oops, sorry, integral of 1/u squared times du. Then we can go ahead and do our integral. So this is u to the -2. So this would go to u to the -1 divided by -1, and then plus c, or -1/u plus c. And u was natural log of x, so this is -1/the natural log of x plus c. For one more problem, if we wish to take the integral of tangent of x, keep in mind that tangent of x is technically sine over cosine. So this is the same thing as taking the integral of sine of x over cosine of x dx. Then we have a cosine in the denominator, right? And sine is more or less the derivative of cosine, right? It just has a negative. So cosine is in the denominator. So it's essentially a 1/u situation. So let's go ahead and set u equal to cosine of x. Then we have that du would be negative sine of x dx. Or sine of x dx, which we do see in our problem, should be equal to negative du. So our integral, therefore, if we do u-substitution, we have 1/u and then net times negative du, or negative integral of 1/u du. Well, we know that integral of 1 over u du is just the natural log of the absolute value of u, and then plus c. A negative out front shows up as an exponent in the log, so this becomes the natural log of the absolute value of 1 over u, or u to the negative 1, plus c. U was cosine, so we are looking at the natural log of the absolute value of 1 over cosine of x, plus c. And then 1 over cosine of x is secant. So we are looking at the natural log of the absolute value of secant of x plus c. So u-substitution is quite a bit more useful than it initially appears. It does apply to quite a few different cases and scenarios. In the next videos, we will use u-substitution to find even more integrals.